the code. So MKL25Z.4, this is the library. So, for example, PDOR, the register that the professor was talking about. So this is the FGPIO type. Okay, so let's go to port B. Port B, what is port B? So port B is going to be started at this address. So the base address is defined as this. So when you say port B, it's gonna make like a pointer to that base address. Okay, so when we add this kind of header file, we have that high-level access to the port. So for example, I can say port B, and then point out to the. I always change the. And then I can access to that pointer, that specific memory address. So for example, in port B, how many registers I had in port B? Port B, this one. So port B, I have PCR, where they are defined. Port B. So I have PCR register, I have so many other registers that are, so port PCR, GPCLR, ISFR, for instance. So here I can access all of them. So I can say, you can see here, PCR, GPC, HR. So I can then add the value. So I don't know, something here. Okay. So this is how these things are connected. So actually, this include file, this library file, is a map from the high-level C code to the memory addresses in the processor. Okay, enough about that. So let's talk about how to. So if we want to make a GPIO port, the first thing that we need to do is the pin configuration. So we need to tell the pin, that specific pin, to act as which alternative. So I can show you that in the data sheet. So signal multiplexing. So in this table, you can see that, for example, we have, so we are in this package, 80-pin package. So for this family for this type of processor, we have 80-pin package, 64 package, 48 package, and etc. Here we have the 80-pin package. So from the schematics, I know that this pin, I can show you in the lecture, there was so in the lecture, you can see that PTB18 is connected to red LED. Let's say that we want to turn this LED on. So what we have to do? First, in this table, we have to find the PTB18. I've already put some notation on the data sheet to make life easier for you. So red LED is connected to PTB18. So this PTB18, which is pin 53 in the processor, can act as either. So the first alternative is TSI0, which I don't know what it is. The second alternative is PTB18. The third alternative is not defined in this processor. The third one is again TPM. I think it's the timer, and the rest is not defined in this processor. So if we don't configure this alternative for that pin, what would be selected as a default is TSIO. Okay, so that specific pin is going to act as a TSIO. So first, we need to say, okay, pin port B. So again, PTB 18 or 19. PTB 18. So let's go to the data sheet, to the port chapter. So we don't want port A, we need port B 18. So let's go to that pin. So you can see here port X PCRN. So port A, B, C, D, E, PCR from 0 to 31. So which pin we want to configure? 18. Okay. So there is a mux at some portion of this register. There is a mux like variable that we have to define. So the mux pin mux control will select which alternative that we want to use for that specific pin. So we want what? We want GPIO. So let's write the code here. So which register, which module first? Port B. Which register of the port B? PCR. Which pin of PCR? 18, exactly. So what would be the value on that? So we need to say, we can do it like this. Let me go here. We have to put 1 in here, okay? And we have to, I mean, we don't have to touch the rest. We shouldn't touch the rest. So we can say, okay, pin 1. It always changes. Pin 1, how many times? 18 times. 8 times. 8 times to the left. So if I do it like this, it's gonna put 0x000. So this value is gonna be stored. So pin 8. It's gonna put this much in that register, but we don't want that. We want to, so these values would be 0. So you can see from here, these value would be, I mean, we don't know what they are, so we don't have to touch them. So what we have to do is first make a copy from that register and then OR it with the current value, with the updated value. So the way that we can do it is just, again, change my keyboard. It's like this. So it's gonna first make a copy, then OR it with that amount of shift, and then put it in the current value. So this means that set GPIO set port B, the 18th bit, as GPIO alternative. So the next thing that we have to do, so now we have the port as a GPIO. The next thing that we have to do is in the GPIO module, we have to say, okay, you want to be an input or output. So in the GPIO module, so you have to go through the datasheet and you will find this register, PDDR. Okay, so we have to say, okay, port, I don't know, port B, PDDR, you want to be what? So it explained that in any GPIO PDDR, if we put 0 in that pin, it's going to be selected as what? As input. Otherwise, if you put 1, it's going to be output. So okay, let's do that. So we want to access PTB. PTB. Which register of PTB? Which register of PTB? PDDR, and we want to put 18 times. So this way we are selecting PTB19 as output. Okay, so the next thing that we need to do is what? Is to configure the, either it should be 1 or 0. So there is another register in here, which is what? Which is port set output register, and we have port clear output register. So as I explained here, so the anode pin of the LED is connected to 3.3. So we need to provide 0 to the other side of the LED to turn it on. Okay? So we need to clear that specific pin. So PTB, which register? PCOR, clear output register. We want to set it to what? To 1. So if we put one on that register, it's going to clear the register, and then eventually we have the port ready. So I didn't configure uh, the clock for the port. I'm just going to show you the halt fault error that's going to happen. So first of all, from the previous lecture, we know that we have to call system core clock update. And okay, so let's build our project to see how many errors we have. Okay, so now I can connect the board to the let's see why. So somehow the bootloader didn't I don't know what's happening. It didn't recognize that. Okay. Okay, so now let the Windows think. Okay, so first we have to use the P micro debugger. So we are ready to program out the board. KEIl25Z. Okay, so and we need to use OpenSDA, connect. So now the board is programmed. When I press restart, the LED won't lit. It won't turn on. So let's go to the debugger mode to see what's the problem. So I can go step by step. So update the core clock. So we have the core clock. We can see the so we know that it's configured to so now it's running at 41.94 megahertz. So we know that it's working. Now let's see port B. Port B, PCR, what? PCR 18. We want to put in the 18th bit. So pin is disabled right now. Now let's go step by step. Okay. So see hard fault handler. So what happened is that is explained in one of these slides. It says by default GPIO module are disabled. Writing to an unlocked module triggers a hardware fault, which we did in here. So if you don't enable the clock, this is the the key to you that you're doing it wrong. Okay, so for that, how to know? How can we set the clock? In the data sheet, there is one part called SIM module, System Integration Module, and in SCGC5, if you go, you can see system clock gating control register. And we need to put 1 in port B. So it says if you put 1, the clock is enabled, otherwise it's disabled. So we need to turn the clock for port B on. So which module we were in? SIM module, yeah. And which register? Again, which register? SCGC5. We have to put, I think 10. Yeah. So port B is 10, yeah, the 10th bit. So we need to put 10. Enable clock for port B. So now let's compile the code and program the board. Now let's go to the debug mode. Start up. Let's run up to here. So now the SIM module, let's go to SIM module. SCGC5. So you can see that the clock is now disabled, clock for port B. Clock for port B is disabled. Now let's run the code. Now it's enabled. You can see clock enabled for port B. Now let's run PCR. Okay, so now we turned that module on, and now you can see the LEDs on. Okay. Okay, so this was basically the.
So this is for one port?
Yeah, this is for one port. So what I need you to do is turn it in this order. Turn the LEDs in. What was the slide? This one. So we need to turn the LEDs in red, green, blue. Okay. So and if you forget what was the order to. The pseudocode is displayed in here. Okay, so first you have to enable the clock. So just if I did this before accessing the port. So if I even do this, it's If I even do this, again I'm going to get a hardware fault. So you have to enable the port before accessing any module, any register in that port, in that specific port. Okay, so then you have to select an alternative for the port. Then you have to make the specific pin, the specific port to the specific GPIO port to output, and then you have to turn the LED on or off. Okay.
This delay function.
The delay function, you can do it in two ways. Either you can say, so the bad way is like write it like this: void delay like int cycles. And you can have like a for int I equal to 0. For I equal to 0, I less than cycle I plus plus, and like this. And then you can call the delay 1 million, I think. If you put it, would be like around 1 second. The other way is using the SysTick timer, which it's a little bit harder. You have to know the interrupt or other thing. Yeah. Okay.
The delay? Because this is the delay, so you see, what's the loop is. So that you know exactly 1 million iteration.